We know that bond polarity is based on differences in electronegativity. Molecular polarity considers the polarity of the entire molecule. Molecular polarity depends on the symmetry of the molecule. Nonpolar molecules occur when molecules have only nonpolar bonds, such as molecules that are made of the same element, such as a molecule of iodine or capital I subscript 2, and molecules that are made solely of carbon and hydrogen, such as ethyne or capital C subscript 2, capital H subscript 4. Molecules that meet these two criteria can be identified as nonpolar based on their chemical formula. Another class of nonpolar molecules are those with high symmetry. To determine whether a molecule has high symmetry or not, we usually need to consider its Lewis dot structure. We'll see that a molecule with polar bonds can actually be a nonpolar molecule if its symmetry is high enough. The criteria for a high symmetry molecule is that there are no lone pairs on the central atom. The central atom is the atom that has more than one bond. Because we need to know if the central atom has a lone pair of electrons, it's helpful to see its Lewis dot structure. The other criteria is that the outer atoms, or the atoms bonded to the central atom, are of the same element. Both criteria must be met for a molecule to be nonpolar. Notice there's no criteria about the polarity of the bonds. On the other hand, polar molecules are molecules with lower symmetry and generally polar bonds. Low symmetry means that there is a lone pair of electrons on the central atom or there are atoms of different elements bonded to the central atom. In a low symmetry molecule or a polar molecule, the more negative end of the molecule is where the more electronegative element is located.